Well, I welcome you all for another presentation on linear integrated circuits and IC applications. Right? In our previous presentation, we have seen certain important parameters or information about the operational amplifier. Right? The very beginning element of this linear integrated circuit is that operational amplifier. Operational amplifier, right? Why is the name operational amplifier? Why is name operational amplifier? Because this particular operational amplifier will performs certain mathematical operations. So this amplifier performs certain mathematical operations, mathematical operations like addition, right? Addition, and then subtraction, right? It performs addition and then subtraction and then integration, right? Integration and then differentiation and then differentiation. These are the differentiation. Differentiation. So these are the various mathematical operations. These are the operations, mathematical operations performed by this amplifier. That's why the name operational amplifier is came into the picture, right? So it can perform addition, can perform subtraction, can perform integration as well as differentiation, or right. So these are what certain important mathematical operations performed by this operational amplifier, right? And we have seen that in the last presentation, the ideal characteristics we have already seen. The very important ideal characteristics of an operational amplifier is that, as already we have seen in our previous presentation, the representation of operational amplifier is like this, right? It has two inputs, okay? So means one input terminal is designated with minus sign, another input terminal is designated with plus sign, and this is the output terminal. Actually terminal 3 is the output terminal. It is 1, actually terminal 1, you can say. This is terminal 2. It has two power supplies. This is plus VCC, you can say, and then this is minus VCC, right? This is minus VCC. These are the input terminals and this is the output terminal in general, right? Okay, so if the input is given to this particular minus that we have seen already, this is called inverting terminal. This one is called inverting terminal. This we have seen already. This is called inverting terminal, right? And then this is called, this particular terminal plus is called non-inverting terminal. This is called non-inverting. This is called non-inverting terminal, right? However, this is the output terminal. Output terminal. In general, you should remember that this is called as pin number 2. It is basically, it is available in DIP package, that is dual inline package. DIP is nothing but dual inline package, okay? Dual inline package. Actually this is called DIP package. Normally it is available in general 8 pin. This is a 8 pin IC. Actually it is a 8 pin IC, right? It looks like this. It is something like this, and it has 4 pins one side and another 4 to the other side, like this. Let us say you can identify pin number 1, 2, 3, 4, and then this is 5, 6, 7, 8. So these 2 and 3 are very important. This is with minus sign, inverting input. this is plus sign actually, plus 3 is the pin number 3 is the non-inverting input. Whatever the 3 output where the third terminal is nothing but actually 6. Basically this is your output terminal. These are inputs actually. So inputs, okay. And similarly this plus VCC and minus VCC. So these are given to, one is for this is plus VCC 7 and then 4 is some minus V. These are two for power supplies actually. And the pin number 1 and 8 are some remaining balance terminals actually. They are not in use actually. No connection, you can say NC. NC. So probably 7 is plus VCC, plus VCC. This is 7th pin actually, and 4 is minus VCC, right? This is minus VCC, like that. Therefore very important is that pin number 2, pin number 3, this we should remember as a pin configuration. Pin number 2, this is pin number 3, output is pin number 6. Your output is pin number 6 according to your pin configuration. This is called as dual inline package, DIP package. This is the general representation of operational amplifier, right? So if ideally speaking, because it has the gain, it is called open loop gain. A is called the open loop gain of an operational amplifier, and in general the open loop gain of an amplifier is very high. Ideally you can say infinite. So because of this high gain, so this operational amplifier will not allow current to pass through that actually. So if you consider the first terminal, through this terminal you can have current I1, and similarly this another terminal, through this another input terminal, that is non-inverting terminal, I2 current flows through this actually, right? As it does not allow the current to flow through this, then definitely you can say that I1 is equal to 0 as well as I2 is also equal to 0, because it is not, it does not allows the current to pass through it, right? That is why I1 equal to 0 and then I2 is equal to 0 at input terminals. Therefore as the input currents are 0, obviously what you can say, it has high input impedance. So if you say that input impedance Ri is very high actually, very high, ideally speaking infinite. So Ri is infinite because of, as current is 0, so that means that it has infinite input impedance. Therefore this is ideally, this gain is also very infinite. That is one properties of ideal character. These are the ideal characteristics of an amplifier, operational amplifier, right? The open loop gain is infinite, the input impedance is infinite, and the output impedance are not actually here with respect to output terminal with respect to ground, right? So that is called R naught actually. This is low, this is low basically, this value is low. Ideally we can say 0. Ideal value is 0, but in general practically you will get certain values which is obviously low comparatively the input impedance. And similarly the bandwidth is also another parameter, and that is also infinite. Therefore there are input impedance is infinite, and then open loop gain is infinite, output impedance is low, and the bandwidth is high actually. The bandwidth is also infinite ideally. These are the ideal characteristics of an operational amplifier. Now let us see the another important configuration of an amplifier, operation amplifier, that is inverting amplifier. After that we will see non-inverting amplifier, how an inverting amplifier will looks like and how the connections will be given actually. Let us see in today's presentation. Just I want to focus on this, right? Inverting amplifier, very important. Inverting amplifier, in short you can say inverting amplifier configuration. So in inverting configuration the op amp looks like this. Let us roughly see the diagram. So this is minus, this is plus, as I already told you. Just you see the diagram how I am drawing that, and afterwards I will explain you. This is called RF, this is called R1, and this is called your signal, input signal I am giving here, or you can call this is Vs, no problem, source voltage. And here at the output I am considering as V0 output with respect to ground. See this diagram. This is the inverting amplifier configuration of a op amp. This is op amp actually, and with gain A. A is the open loop gain, you can say, or otherwise it is a operational amplifier. Always remember that the operational, very important point I am telling you. So the operational amplifier will alone not be used in electronic circuit. Operational amplifier will never be used alone in electronic circuit actually, no. It requires some extra components, some passive component. Along with certain passive components, the operational amplifier will be used. Say for example, if you see this particular configuration, so here resistors, two resistors I am using, one is R1 as well as R suffix F. These are the passive components. Normally passive components are resistors, capacitors, inductors, whatever that. But the passive component, along with these passive components, the operational amplifier will be used. But it itself, the operational amplifier itself will not be used alone, no. Right? So it works with the passive components, maybe resistors, maybe capacitors, maybe inductances, no issue. As per the requirement, as per the application, we use to those passive components. So as far as inverting configuration is concerned, we need resistors only, as shown in this configuration, as shown in this figure. So carefully see here. So this R1 is normally the resistor, and this RF you are able to see here, RF is called as the feedback resistor. This is called as feedback resistor. This is called feedback resistor because if I connect this connection from output to the input, this forms a closed loop actually. In general, this is a closed loop actually. Because of this is making a closed path. Otherwise, if you do not have this particular looping, then it is called a open loop system. It is a amplifier in open loop. So as and when we have this connection of this particular feedback resistor, if we are connecting between output to input, then there is a closed loop is formed. Now with this, you can find out the ratio of output by input. Output is V0, input is Vs. You can find out the ratio. V0 by Vs is our interesting point here. What is the voltage gain? What is the voltage gain? That is our interesting point in this. Nice, very nice. Let us see carefully. Now, this is what, so means that what you can say in inverting amplifier configuration, this is my input actually, Vs is source voltage is my input. So this particular input where I am applying, if you see that this particular input I am applying at minus terminal, and in this inverting amplifier configuration, the plus sign means that non-inverting terminal should be grounded. So non-inverting terminal must be grounded, whereas the input is applied to the minus sign, then it is called as an inverting amplifier. Always remember that in inverting amplifier, the input is applied to the minus sign. Right? What is the name inverting? Inverting is nothing but, so this amplifier amplifies the input signal, not, okay, it amplifies the input signal, right? And again, so at the output stage, this amplifier will inverts, means your output is inversion of the input actually, right? So it inverts the input. So at the output you will get the inverted form of the input. At the output you will get the inverted version of the input actually. That is why the name inverting means. right? So that is what, remember that the input is applied to the inverting terminal, where at that time the plus sign, the non-inverting terminal, this is non-inverting terminal, always remember these two terms widely we can use throughout this particular topic and throughout particular this unit otherwise. Okay, inverting terminal minus is inverting terminal, plus is non-inverting terminal, right? This terminology you should remember. Therefore, so in inverting amplifier, non-inverting must be grounded, right? So because of this inverting amplifier, what is the ratio of output by input? That is V naught by Vs, right? So in order to find out the ratio of output by input, let us imagine that I can imagine here in this particular, I can imagine some voltage V1 will V1. Assume that some voltage V1 will be there here. I assume that V1 equal to some V1 will be there, right? Now so because of this voltage source, some current will flows through this particular resistor I1. Let us say I can call it as some current I1. Because of this voltage source, current I1 will flows through this, right? So this particular current, I already explained you that the op amp will not allow this current to pass through it because of the high gain. Because of this high gain, this current, whatever current I1 is there, it will not flow through this amplifier. Then how it will flow? I1 flows like this. So it flows, I1 flows from source to up to this nodal, and from here it goes up and through this RF feedback resistor, and it flows through that and it reaches to the output. This is the flow of your output, I mean the current I1 flows like this. Clear? Therefore, that is the flow of current actually. It will not flow through this op amp. That we should remember. Therefore, so imagine that at this particular node, okay, let us say I1 is the current flowing through this, and afterwards this same current flows through this, and again the I1 is flows through RF also. I1 flows through RF also. Now use your I mean KVL. By using KVL at this point, for this loop actually, for this loop, okay, for this loop, how you can write? I can write two important or one expression I can write here, so that from that expression I can get easily what is the ratio of V naught by Vs, output by input. And before going to write that particular expression, I would like to explain you one more very important point here. So I think I already covered this particular point in our previous presentation. So this is the feedback loop actually. This particular loop, if you connect this loop, RF loop means feedback resistor. This is the feedback resistor. This resistor I am connecting to this minus sign. Therefore, in this particular we are using negative feedback, right? In inverting amplifier, what is the feedback we are using? Negative feedback. Sometimes this RF can also be connected to the positive sign sometimes. So that is called as positive feedback. Therefore, both feedbacks will be used in op amp. Either you can use positive feedback or you can use negative feedback also. That is another important point. Okay, just for the time being, you remember that if this RF is connected to the minus sign, then it is a negative feedback, and if it is connected to the positive terminal here, then that is called as positive feedback. That's it, very simple. Now coming to this particular loop, so this is the loop actually from here to this particular loop. So for this loop, if you apply the KVL from this loop, then what I can say, simply I can write Vs minus, let us see one simple expression. This is Vs minus V1, right? Vs minus V1 by what I can write? R1, no? Can I write like that? For expression I1 I am writing Vs minus V1 by R1, that is equal to, right? At this particular node I am applying nodal voltage, right? So and from here to here means V1 minus V0 here means V1 minus V0 by what you can write? RF. Clear? Vs minus V1 by R1 at this particular node, that is equal to, means that whatever the current, means that this is the expression for V by R actually. V by R is nothing but I. So for this I1 I am writing the expression, this I1 is equal to this, nothing but it is a KCL, flowing current and leaving current, input current at this node to the leaving current. It is KCL actually. Okay, this implies what we can write. Remember one more important point now. So in operational amplifier, one important concept will be introduced, that is called virtual ground. What we call virtual ground. Virtual ground concept will be widely used in op amp. So virtual ground is nothing but, let us say, so this plus terminal we have made to ground means that it is at zero potential now, zero voltage. Whatever the voltage appears at this particular terminal, the same voltage will appear here also at V1 also. That is what virtual ground concept. So whatever the voltage appears at plus sign, and the same voltage automatically appears here, right? Therefore, according to this virtual ground concept, V1 is now, as this is at zero potential, now V1 is equal to what? Obviously 0. Therefore, wherever V1 is there, you make it 0, then you will get Vs by R1 is equal to, V1 is 0 obviously, minus, then you will get V0 by Rf. And this implies further, from this you can write no, V0 by Vs, output by input source voltage, it is minus what you can write, Rf by R1. Very simple, very simple. See how simple it is. That is the ratio of output by input. This is the voltage gain. This is the gain of an inverting amplifier. This is the gain, Rf by R1. So Rf by, it is the simply ratio of the feedback resistor to the, I mean you can call it as input resistor, no problem, R1. Therefore Rf by R1. So it is the ratio of the resistors only. Therefore the gain of the inverting amplifier, it depends on the gain of the resistor or ratio of the resistors. Okay, the amplifier, the voltage gain, this is the closed loop gain you can say. Now V0 by Vs is nothing but the closed loop gain of this particular inverting amplifier, and that is in terms of the ratio of feedback resistor to the input resistor R1. So as the minus is there, this minus indicates that inverted. So it inverts the input actually. This is the important relation. V0 by Vs is equal to, simply you can remember, minus Rf by R1. That is the ratio. Or otherwise, sometimes if you want to calculate V0, therefore V0 output is equal to minus Rf by R1 into Vs, input voltage. That's it. This is whatever output voltage. I think you have understood this concept, and I hope that I make you some sense of it. And okay, so with this I finish off today's presentation, and we'll meet in the next presentation, right? So please don't forget to give your observations and suggestions and comments, and don't forget to share this important information to your friends and then colleagues, whoever really need of it, right? So we'll finish off here and meet in the next presentation. Till then, have a good day.